momentary lapse of transmission there, but we're back. Where did we get to? Roger, how are you?
Oh, we're fine. I'm fine. Everybody's fine.
Good. Aaron, how are you?
Hi there. Good to see y'all. I'm doing well myself. Very impatiently waiting for T. Corona Borealis, who is late to the party.
Well, we're going to talk about that. So
good.
Don't worry about that. Lou, how are you?
Well, I'm doing well up here in Maryland, but so many people are not doing well from Florida up through North Carolina from the impacts of Hurricane Helene. So we're kind of following those rescue and, well, I guess it's all rescue efforts right now, and just trying to get enough water, internet, power, the basics.
Yeah. The devastation in Florida I was looking at today is incredible. Absolutely incredible. Those poor people. I mean, our hearts go out to them. So,
Andy, I don't know if anybody else is monitoring this.
There's anyone watching. That's probably me.
Yeah, and me. But it seems that we started and then we stopped again. But now it's cut the stream off.
What's happening?
I think it started again.
Has it? Good.
Yeah, I think there's just a little more delay than we're used to.
Yeah. Right. Can anybody tell me exactly what's happening at the moment on YouTube?
Still running.
Okay, great. Well, we'll carry on then. Sorry about this. Viewers, as you know, the perils of live transmission. We do get glitches from time to time. We hope it hasn't spoiled your enjoyment, and we are very grateful to have you here. Been a bit of a busy week in astronomy. So what have we got coming up for you this evening? Well, today we're going to be having a look at the 10 weirdest exoplanets. Now, I think, when we started detecting planets orbiting other stars, we didn't really know what to expect out there. We didn't know whether we were going to find solar systems very much like ours with similar planets, or whether we were going to find completely different types of planets and solar systems, or star systems, should I say. But in the event, now we've discovered more than 5,000 exoplanets, and there are some real weird ones out there. Of course, such a list of the 10 weirdest ones has to be totally subjective, and there being no objective criteria to measure these things. What makes something weird? Well, I think we can ask Daz about that. But in the event, yeah, you are an expert. But I'm going to give you my 10 favourite weirdest exoplanets. And if you know of any others, then tell us about them in the chat. And I'm sure Lou might know of a couple that should have been on the list or might have been on the list. But we can discuss that afterwards. So just to tell you about a few things that are going on. A bit later in the month, we are honoured and delighted, or we will be honoured and delighted, to welcome Anna Menon and Sarah Gillis, who were two of the astronauts on the recent Polaris Dawn mission. And they will be joining us for chat on Space Oddities. We haven't confirmed a date yet. We'll put the details in Facebook as soon as we have. So there's that to look forward to. Michael, do you want to talk a little bit about our guests from Saxavord as well?
Yeah, we got Robin Huber in 2 weeks' time from Saxavord. He's based in Germany, but he's one of the senior guys at Saxavord. So just got to confirm he's coming on the 15th. But yeah, that's the date we've arranged for him at the moment. So keep in touch with him.
And for anybody that doesn't know, could you just tell the viewers a little bit about Saxavord?
Saxavord is the first vertical launch space flight centre in the UK, based at Saxavord on the Shetland Islands. It'll be the most northerly launch site for the UK, mainly for polar orbits, for no Earth orbit, basically.
Right. Okay.
So looking forward to that one. So Robin Huber has agreed to come on the show to talk about that.
Absolutely. So that'll be interesting to chat about Britain's second spaceport, should I say?
First vertical one.
First one to actually launch. Mind you, let's not count our chickens, because RFA had a slight disaster at Saxavord.
Of course they did, yes.
Yeah, a couple of weeks ago. when an attempted static fire blew up the rocket.
So
But this is progress.
That's obviously caused delay for first flight.
Yeah,
they're confident that they'll get back together as soon as they can.
Yeah, absolutely.
Yeah.
Well, thank you, Michael.
Yeah.
So also tonight, of course, Daz is going to be giving us his solar watch and what's going on the sun. I think it's been a bit of a quiet week, but we shall see. Daz has got all the gen on that. So just usual housekeeping stuff. Don't forget that we still have the Space Oddities merchandise available in the Space Oddities shop. And you can scan the link to go to the Space Oddities shop, scan the code. I'm sorry that the link hasn't popped up in the chat like it used to. This is an ongoing problem I'm working on with the people who make our streaming software. We're working on that, but so far we haven't had a solution. Anyway, T-shirts and hoodies available in the Space Oddities shop. T-shirts are £25, including UK postage and packing. And the hoodies start at £40, including UK postage and packing. And please add £10 to the value of your order for foreign orders. So that's that. Also, in terms of space events happening, I think primarily at the moment, if not exclusively in the UK, do keep an eye on the Facebook chat, which is entitled Your Astronomy Events, because people have been posting UK events in there. So if you're looking for an astronomy event to go to in the UK, you can have a look in there for the details. So just go to the Facebook page, Facebook group, and click chats, and then click Your Astronomy Events, and you'll see everything listed. Also, of course, if you know of an astronomy event that you'd like to tell people about, then put the details in the same chat, and we'll have everything in one place. And as I said, there are several events that have been posted in that chat at the moment. So go and have a look, and perhaps there'll be an event near you that you might like to go to. So there we are. So that's the bit of the housekeeping out of the way. Just before we start with the news, something for you to think about, viewers, as we're going to be talking about exoplanets tonight. What planet in the solar system do you think that extraterrestrials might find a little weird when viewed from a long distance from the solar system, the same sort of distances that we view exoplanets for? Now, obviously, this is going to be subjective again, because our concept of weird will probably almost certainly not be extraterrestrials' concept of weird. In fact, they may not have a concept of weird. But if you can think of a planet in our solar system that from a distance might look exceptionally weird, then tell us about it in the chat. Have a think about that. So what we're going to do now, we're going to go straight into the news for this week. So let me just get myself sorted out here. And there have been several nice stories in the news this week. Let me just get organized. And one second. Okay, so the first thing is this is a nova alert. Now, there's an imminent nova in the constellation of Corona Borealis. So what's all this about? Well, just a brief description of what a nova is. So a nova is all to do with a white dwarf star. And when you have a white dwarf star, which, as you may know, is a stellar remnant, which is a phase of life that stars like our sun will end up going through after it's gone through its red giant stage. And when you have this orbiting another planet, its gravity is so strong that it starts pulling material, principally hydrogen, off the parent star, and the hydrogen accumulates on the surface of the red dwarf. Now, long time ago now, the very famous Indian astrophysicist Subramanian Chandrasekhar realized through mathematics that the accumulation of material on the surface of the white dwarf cannot continue indefinitely. And what happens is that once the increasing mass of the white dwarf, because of the accumulated material, reaches 1.44 times the mass of the sun, a massive thermonuclear explosion happens on the surface of the white dwarf, which blows off the outer layer, And this explosion, which is visible across the galaxy, is what we call a nova. Now, once that has happened, and the mass of the white dwarf goes to under the 1.44 mass limit, which is, of course, now known as the Chandrasekhar limit, after the famous astrophysicist who discovered it, the white dwarf starts accumulating material again from its parent star, and the whole cycle repeats. And we're about to see one of those that last happened 80 years ago. And this is known as T Corona Borealis, the white dwarf, and it's in the constellation of Corona Borealis. And we're very lucky that what's been happening is that there's been a sudden dimming of the white dwarf, which is commensurate with an imminent nova happening. Now, there have been predictions about exactly when it's going to happen. The media predictably have been full of ridiculous stories. One article I said nailed it down to happening within the next 2 days, and that it would light up the sky, neither of which are true. It could happen any time now. And when it does happen, it possibly will be as bright as the North Star, Polaris, and you'll be able to see it with your naked eye in the night sky. Now, just to show you exactly where it is, here's a map of Corona Borealis. So where you start, if you follow the tail of the plough down across the sky, you come to the bright star Arcturus. And as this map shows, if you go left of Arcturus, you come to the constellation of Corona Borealis, or the Northern Crown. And as you can see in this image, there's an X where the nova is going to happen. So do keep your eyes open for this. It will be a new star in the sky, hence the name nova, for new. And, this one, as I said, hasn't been seen for the last 80 years. So it's quite an event. Just to let you know, also, another thing that can happen with white dwarfs is that if the temperature of the star of the white dwarf at the core is sufficiently high, instead of a nuclear explosion on the surface, which blows off the outer layer, it can actually blow the white dwarf apart if the temperature is sufficiently high in a massive explosion, which is known as a Type 1a supernova. And obviously, when that happens, it's over for the white dwarf. It's completely destroyed. Although there is reason to think that they can survive them and become known as what's known as a zombie star. But anyway, that's another story. But basically, this accumulation of material on the white dwarf can end up as a nova, which repeats, is cyclic, like the imminent one, or can result in a supernova explosion, which destroys the star altogether. And if we have any news on this, we'll put the details in Facebook. But it could be that by the time we return next week, we might be able to see a nova. And how long is it going to last in the sky? Well, it's a bit difficult to predict, but certainly it will only be at its brightest for maybe a few hours before it starts fading, if past performance is anything to go by. But it will be visible for quite a long time in the sky, we think. So we'll let you know about that. Okay, let's move on. Now, the next story is about the Parker Solar Probe. As you may know, the famous NASA Parker Solar Probe, which is getting very, very close to the sun and has made a series of close approaches to the sun. The closest approach to the sun is known as perihelion. So it's made a number of perihelia, up until now 20, I think, 20 or 21. And we're learning a lot about the sun from actually within the sun's atmosphere, within the corona. This spacecraft obviously had to be exceptionally designed to withstand the heat of the sun. But it was already the fastest human object on record, and it's about to break its own speed record. So what's actually happening? So it reached its 21st perihelion of the sun 2 days ago, and it got within 4.89 million miles from the surface of the sun. So incredibly close to the sun. And on the 6th of November, it's performing its 7th flyby of Venus, because what happens is that it goes close to the sun, then goes out to Venus, picks up speed around Venus, and comes back into another perihelion. And so far, it's completed 6 around Venus. And on Christmas Eve this year, it's going to reach the speed of 119 miles per second. Now, that is an incredible speed, and it will then become the fastest human-made object ever to fly in space, 119 miles per second. Unfortunately, after that, there are only 2 more perihelia planned, as mission scientists think that wear and tear on the spacecraft because of the intense heat is going to eventually kill the spacecraft sometime next year. So NASA have only planned 2 more perihelia. However, if NASA engineering in the past is any guide, it may well end up lasting a lot longer than that, and they may be able to perform more perihelia and getting perhaps even closer to the sun. At the moment, the spacecraft is in excellent health and working perfectly.
My understanding, Andy, is that there is some work already being done on an extended mission plan.
There we are.
Whether that gets carried out or approved is still up for grabs. But.
Yeah, because it has survived incredibly well, hasn't it, up to now?
It has.
Incredible engineering feat to build something that can...
Nominally.
Yeah, nominal. Yes, absolutely. So here are the Venus flybys. You can see the third one down on the right is the upcoming one in November, and it shows you where the others have been. So we just hope that we see more perihelia. This is an interesting image from the Parker Solar Probe. This is Venus, and the black and white image is an image taken by the Parker Solar Probe. And the colored image is an infrared image from the Magellan probe, which investigated Jupiter some years ago. Now, what this is showing is that the Parker Solar Probe was very lucky, because as it passed Venus, believe it or not, there was a break in the clouds. Just for once, the clouds of Venus parted and enabled the Parker Solar Probe to take that black and white image of features on the surface, which, as you can see, lines up very, very well with the infrared image. So I just thought I'd show you that, because it's very, very rare that we can see anything on Venus because of the thick atmosphere. And it's even rarer that the clouds actually part to allow us to see directly to the surface. So that's another fantastic observation that the Parker Solar Probe has made. And here's a video taken as the Parker Solar Probe is actually flying through the corona of the sun, and you really get a sense of perhaps the speed that it's moving, and it's actually inside the atmosphere of the sun. Now you'll see a structure pass on the right hand side. There it goes. Anybody know what that is? There we are. It's the Milky Way.
It was labeled.
Yeah, it was labeled. Yeah, but there we are. That's the Milky Way. So those are stars in the background you can see here, but you really do get a sense of the speed at which that spacecraft is flying through the sun's corona. And you can see...
Andy,
yeah.
I'm so sorry to interrupt you again, but I noticed something very interesting on the right-hand image. These 2 bright dots that are kind of near the top.
Yes.
Is this a parallax effect? One looks like it's passing the other. They're not fixed in.
Yeah, do you know, I noticed that earlier, and I was thinking exactly the same thing. That must be a parallax effect.
Isn't that
Aliens.
Yeah.
Is it planets?
Well,
And the parallaxes brought them together.
Yeah. That's a nice video from space.com. I don't actually know what that is. Perhaps we could look into that. Interesting. Very interesting.
Because before you just see the Milky Way, there's a big bright one.
Yes.
Which is obviously a planet. I'm just wondering if this is 2 planets, and because it's moving so fast in the parallax, it's giving us a conjunction of 2 planets.
Could well be. I wonder how we can find that out. Might be difficult, but
call Johns Hopkins.
Yeah, absolutely, John Hopkins. Next story is to do with black holes, dark matter, and Mars. Now you might think, well, how can Mars possibly be related to black holes and dark matter? Well, let me tell you, there's an idea. It's not even a theory because there's no observational evidence to promote it from a hypothesis to a theory. But the idea is this, that in the very, 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 very early history of the universe, almost immediately after the Big Bang, there were countless numbers of black holes spontaneously created from matter collapsing in on itself, clumps of matter collapsing in. And those black holes may be only about the size of an atom, but they are still around in the universe today. So lots of people have put this forward as an idea as to what the elusive dark matter might possibly be. It might be these so-called primordial black holes. And if so, if they do exist, they might actually exist in our solar system. Our solar system might be filled with them. Well, I don't know about that, because although these black holes, if they do exist, these atom-sized black holes exist, they're going to have the mass of about an asteroid. And I think we would have noticed that before now with the gravitational effects that it was having on objects in the solar system. Well, interestingly, a paper has just been published claiming that it explains one thing. Mars has a bit of a wobble in its orbit, and this is not explained. Its orbit actually does wobble a bit. It's not absolutely static. And the paper says that it could be that it's one of these primordial black holes in the orbit of Mars that is pulling on the planet, causing the wobble. Now, I don't know, if there's any, obviously there's no observational evidence for this because, as I said, we've never observed these primordial black holes. And in fact, a series of observations done maybe about 5 years ago to look for these primordial black holes affecting the light of stars as they pass in front of a star didn't find anything. They only found, I think they studied thousands of potential events that could be down to primordial black holes. Some of them were down to normal common or garden, if there is such a thing, black holes, stellar mass black holes. But they only identified out of a few thousand observations, maybe 3 that could possibly be due to these primordial black holes. But, statistically really not significant. So we don't know if these primordial black holes exist, and we don't know if they do explain the wobble in Mars orbit. But it's an interesting thought. So I just thought I'd...
When you have to publish or perish, it's amazing what you can come up with.
Yeah, well said, Lou. Yeah, absolutely. So, don't know if this holds any water at all. But, lots of scientists do seriously think that these primordial black holes formed at the beginning of the universe could still be around. So there we are. Just thought I'd do that. And we're going to stay with Mars now. There's another Martian mystery. Astronomers of planetary scientists have discovered around the Martian pole, predominantly the North Pole, have discovered lots of underground structures, and we don't know what they are. Now, this is all to do, if you look at this map, there are about 20 of them, which are the circles here, underground. And what they've discovered is that there's an ancient ocean bed on Mars around the North Pole. And these are structures that are buried under the bed of that ocean. What they are, and one quite nicely shaped like a dog, apparently. These structures are really weird, and we don't know what they are. Have you heard about this, Lou? Does this ring any bells with you?
I've heard of subsurface structures like lava tubes and things that might be formed by volcanic activity, but otherwise, no.
No? Okay. Well, this is something new then. There's another weird thing as well. The Tharsis Bulge, which is the area where the big volcanoes are on Mars, is rising. It's lifting up. Sorry, let's go back to that. And the there's a layer, they think, of something connected originally with volcanism that is being pushed on from underneath. And they're not quite sure what's causing it, but the Tharsis bulge, that whole area of the planet where the biggest volcanoes are, including Olympus Mons, the biggest volcano in the solar system, as you can see here, it's rising up slowly. So that's another mystery at the moment. What's causing the pressure from underneath to rise up? As far as we know, Mars is volcanically dead, but something nonetheless is causing that whole area, the Tharsis, the so-called Tharsis bulge, where the big volcanoes are, to actually lift up. So that's quite interesting.
So, Andy, do we have any information on the rate at which it's rising?
I couldn't find that out, actually, Aaron. It just said that it's rising. So yeah. Let me just consult my notes here, Aaron. Let's see whether there's anything in the notes. Just actually give me a second. We'll come back to that in a second. So just let me come back here. There we are. Just give me 1 second, and I will consult. That's kind of weird, isn't it? That should be happening.
So it seems that it may be the result of anomalies in the mantle, which kind of lift up the lithosphere, and this can happen because there's no freedom in the surface. There's no plate tectonics or any other force, other systems that will give you freedom to adjust for that.
No, that's correct. So let me just go back in. I've got some notes here. So let me just go back in here. Okay, so what it says is this. I hope you can see this. No, that's gone again. 1 second. All right, let me just read the notes to you that I've got. And it says, and I quote, that's the wrong one. So I've got so many windows open here. Okay, so it says that there are large structures under the huge volcanic region of Tharsis Rise. Known for its preponderance of volcanoes, the area is also home to the solar system's largest volcano. Although volcanoes are very dense, the Tharsis area is much higher than the average surface of Mars and is ringed by a region of comparatively weak gravity. This gravity anomaly is hard to explain by looking at differences in the Martian crust. According to the researchers, a light mass of around 1,750 kilometers across and a depth of 1,100 kilometers appears to be actively pushing up on the entire Tharsis region. They suspect this light mass could be a massive plume of lava hidden deep within the Martian interior that is slowly working its way to the surface, and it may indicate that Mars is still active. So there we are. That's kind of interesting. Yeah. Yeah, okay. Let's come back here. And, okay. Right. So, let me just try sharing that again. 1 second. Sorry, I'm all over the place this evening, trying to do too many things at once. Okay. Right. Okay, let's go back. Okay, so going back to here. Moving on from Mars. Let's that's got me. Okay, so the next story, again, more black holes, I'm afraid, and this concerns a swarm of black holes that are moving through the Milky Way. Now, if that sounds terrifying, please don't worry about it, as ever. This is to do with a globular cluster called Palomar 5. Now, you can see in the insert at the bottom right here, this is the globular cluster in question. It's some 80,000 light years away in the constellation of Serpens, and it was discovered in 1950 by the German astronomer Walter Baade. It's very old, as all globular clusters in and around the Milky Way are. It's about 11.5 billion years old. Now, this globular cluster is really unusual for a couple of reasons. Firstly, it's unusually large. It's got a radius of 65 light years, but it's got commensurate with that. It's actually got a low number of stars for a globular cluster. It's actually got only around 10,000 solar masses. But the other thing you can see in the big image, which is an enhanced image, and the lower image, is that it has these so-called tidal tails. These two streams of material on either side of it. And they've done some research into this, and they think what happened here is that because the globular cluster does not have a high density, stars over billions of years have been able to escape from the globular cluster. And this is what we're seeing in the tidal tails, the stars that have actually escaped the globular cluster. Now, what this means is that lighter objects like stars can escape the cluster, but heavier objects like black holes don't. And they think in this globular cluster, there are now around 100 black holes in the globular cluster, making up more than 20% of the total mass of the cluster, actually, inside Palomar 5. So there is this swarm of black holes, but they're inside this globular cluster, which is really, really interesting. So I wonder what, if you were inside that globular cluster, what it might actually look like. Lots of black holes in the sky. So there we are. So that's that story. Staying with black holes again. Astronomers have discovered a black hole with the longest black hole jets ever. And these jets are absolutely huge. And it's the biggest structure of galactic origin that we've ever seen. It's been named Porphyrion after the king of giants in Greek mythology. And anybody want to guess how long these jets are extending from this black hole? Anybody?
1,000 light years.
1,000 light years. Right. Any other guesses?
I'll say about 1 million.
About 1 million. Right. So here we are. So here is the actual figure. End to end, they are 23 million light years long.
Yowza.
Exactly. Now, if you were to shrink these jets to the size of the Earth, the black hole would be about the size of an amoeba at the center of the Earth, and the jets extending away from that to be the size of the Earth. So if you can imagine an amoeba spouting out jets to the radius of the Earth, that's what we're talking about. Nothing this big has ever been seen before. We don't understand the physics exactly of these black hole jets. We know that when black holes try to consume lots of material, some of it is funneled to the poles and ejected by the incredible magnetic fields and focused by these incredible magnetic fields as these jets of material across space. But to find jets that in total are 23 million light years long is an absolutely astounding discovery, because this is on the scale of the cosmic web, if you like, the arrays and streams of galaxies from which the universe is composed. This is an astonishing size for black hole jets. And obviously astronomers are researching this and trying to find out what the hell is going on there. So that's an amazing discovery. So there we are. What do you think about that, guys? That's the universe never ceases.
Fantastic, that is.
To amaze us. It never ceases to amaze us. So
I'm assuming that was an artist's impression.
No, that was an actual image.
Oh, was it?
Yeah, that's an actual image of the jets. Yeah.
Oh, okay then.
Yeah, amazing. There we are. Okay. Right. Well, we hope you're enjoying yourself. Don't forget, if you have any chats or questions, comments, suggestions, ransom notices, threats, anything you want to say in the comments, please put them in there. And death threats, threats of violence, anything at all. We're always glad to hear from you, no matter what you say. So thank you very much indeed. We're going to move on now. And as usual, we're going to go straight over to Roger. So Roger's going to tell us what's up in the night sky. And I gather we've got quite a large gallery tonight.
Yes, thanks to Pete Williamson.
Who?
But he's got millions more. He's got millions more. So
Yeah.
we'll never be short.
Yeah. Yeah. So, Lou, I gather you have to go now?
Yes, I have to go teach my astronomy class at Marymount. We're playing Astro Jeopardy today.
Oh,
Ooh.
fantastic! Oh, I'd love to be there for that. That should be good fun.
I can set it up for us on Space Oddities, and we can play. That might be something.
You've just
fun.
taught yourself into some homework, Lou.
All right.
Ooh.
Take care, all.
All right, take care, Lou.
Cheers, Lou.
See you,
Bye.
Lou.
Cheers, Lou.
Ow.
Right, okay. So, are you all set and raring to go, Roger?
Oh, I'm raring.
Okay, all right then. So,
Okay, so here we go for the first full week of October. Da, da, da. So we're coming out to the new moon over the next night or so. So things might look a bit up if there was ever a clear sky to see. So there we go. I've only seen the moon just a few days ago, and this was it before it got to the almost new moon stage, which it was about 1% or so before that all disappears. But we're still seeing the summer triangle at the moment, and looking over towards the east, Jupiter is shining brightly in Taurus, and we've also got Uranus in that constellation as well, and looking further towards the north of there is Mars in Gemini. So there we go. So things are looking quite good. So things are interesting if you want to try and get something of interest photo opportunity wise. We do have Jupiter near the Crab Nebula during the next week. Okay, so and with Mercury very close to the Sun from our viewpoint, that's not going to be a good thing to see. So Venus is still very low in the horizon, but that is an opportunity still to see, but it will become a bit more easier to see as the evening star later through the latter parts of this year. So things could be a bit more interesting. So in a couple of nights we have Titan to the south of Saturn, should you wish to see that view, and that will be during the latter part of the 3rd, which is on Thursday, so late evening for that. And then 3 days later we've got a transit of Dione going across the surface of Saturn, and that's for those who want to stay up to about 1 o'clock in the morning. So good luck with that. Of course, these shadow transits are more visible to us due to the very low angle tilt of the rings. So obviously anything going above or below the rings will become more apparent. So we have to make most of that opportunity. We've also got an interesting conjunction if you've got a low clear horizon for the 5th of Venus and a very thin crescent moon. So shortly or so after the new moon, we've got a very thin crescent and a Venus directly above it. So that might help give you a clue of where it is, should you be able to rush it. I've just put this up at the moment. It's Schunnesen Atlas, which will become visible in our evening skies later part of this month. But I'm only putting the dates up from about the 16th because it will become visible a few days before that. But obviously it's still rather bright in the night, in the evening sky from after sunset to make a clear sighting of that. But these dates I've put up from the 16th will become more obvious once the sun has gone down. And as you can see, it's going from a calculated roughly just about magnitude 5 going through to magnitude 7 during the earlier part of November. But it's looking quite promising. There's been lots of pictures taken in the southern hemisphere, and it looks to be doing quite well with an extremely long tail. So fingers crossed for a reasonable viewing of it over the next few weeks of October. So if you're looking down towards the southwest, it'll be coming up through Libra and through Ophiuchus. So it should be of interest to keep an eye out after sunset. We do have some interesting things to see from the James Webb. This is Galaxy GS NDG 9422, and it seems that the gases coming out from that light is covering the brightness of the stars that are within this area. So it's become quite interesting to have the gas outshining the stars, which are concealed within the within this area. So could be an interesting thing to keep an eye out for. Okay, here we go for the gallery. I've just put one in due to the large number of entries. And this was one that I took at the weekend. It's just a picture of the Milky Way over a derelict barn.
Lovely.
But it was an interesting outing from our club members. We seem to have got a little astro group of Milky Way photographers in our camera club, and we're going out on these boggy, muddy fields, going to get some foreground interest of derelict buildings and places of interest to go and capture these things. But yeah, unfortunately, there's a bit of a glow behind it because that's the city of Wells, which is protruding out from behind there. So it didn't come out too bad. Right. So we've got some processed images of from Ian from what was shown from John's talk the other week, and this is before and after processing of some images from the Juno spacecraft of the surface of Jupiter. So some work done some interesting work there.
It takes quite a bit of detail there.
And we've got a few from Peter here. And he says he's got millions, so we can expect a large gallery each week. And as you can see, some amazing details of the cloud activity and belts of Jupiter, all from the Juno spacecraft.
Lovely.
I don't know, that may be, is that the great red spot there, Peter?
No.
I'm going to say it's look a bit faded if it was.
Yeah, no.
And a bit small.
And yeah, here's one that Peter did of Ganymede.
Wow.
Yeah. Some quite
really
big
shows the
impacts
patchwork,
there.
doesn't it?
Yeah.
Really shows the patchwork nature of it.
Yeah.
Some nice, as you said, nice impacts there. And also you've got the ripples at the bottom of the ridges.
Yeah, and you've all got a lineup of impacts in a row there over on the left-hand side.
Yeah, that's brilliant.
Very good. And we've got one of Europa. Look at that.
Oh, look at that.
I love the light in that image. It's just...
It's almost like the looking into somebody's eye with all the blood vessels at the back.
Oh, that's nice.
Yeah.
Yeah.
There we go. And something a bit nearer, we've got a Perseverance image of some of the Martian surface.
Wow. The colours are amazing.
All you need there is Matt Damon in a spacesuit.
Yeah.
All right. Yep, absolutely.
See, the Germans haven't hit the beach yet. There's no towels.
No. And here we can see some of the dust that's accumulated over the surface of Perseverance there as well. Ow. Yeah, needs a good blow over.
It's going well, isn't it?
Absolutely.
Yeah.
So here's one he's done with the iPhone 15 with a 15-second exposure of the Milky Way.
Wow.
Never.
Very nice.
Absolutely.
The iPhone.
Mm.
God.
An iPhone 15, but this is a 15-second exposure.
Wow.
Is that from the back
Amazing.
garden, Pete?
Hey,
Yeah.
Is that from the back garden?
no, that's from the centre of Oswald Street.
Oh my God! All right.
Mm.
Wow.
So it's not even from a dark site. It's just showing what I was just trying to play about with the iPhone to see what it would actually do, and I was quite surprised, to be honest. But I mean, that was just the first test. As obviously you can do a lot more with it.
Yeah.
Mm.
When you go
Yeah,
into the pro settings on these latest phones, it's amazing what you can do, especially with nightscapes
Absolutely.
like that. I mean, that's a lovely image.
But that
Lovely.
wasn't using any special apps. That's just using the camera app that come with the iPhone.
Oh well,
Exactly,
that's using it
Yeah.
the built-in camera. Yeah.
Yeah, you can use it because they've usually got the pro settings, haven't they? So
Yeah.
that's where I usually get. Well, on my Samsung, that's what I have to do.
Yeah.
But,
Wow. That's amazing.
Well done.
I'll have to give that a try.
Right. And here's one from Pete with a Takahashi 102 of the Andromeda.
oh, look at that!
That was from the back garden.
Wow.
That's a good one.
That's amazing.
That's a proper one. That proper good one. That.
Yeah, I'd agree.
I
You're
must stress to Ian. Ian says he needs a little practice. Ian, this was my job for about 30 years, so don't worry about it. I was working with the Juno data and the Perseverance data as part of my job. So I've been doing it a long time.
Amazing.
Right. Oh, look, somebody else has put some in. We've got some from Jerry of the Sol Nebula in Cassiopeia with his usual setup. And this is what we've got.
Oh, that's lovely.
Wow.
We see it the other way round this time. But you usually see it sort of face down. This is face up.
Yeah.
Mm.
That's fantastic.
good.
Well done, Jerry.
Well done, Jerry. And we've got a couple from John, and this is of the Heart Nebula.
Wow.
Oh yes.
Well done,
Get
John.
well soon, John. Get so.
So we've just seen the Soul, and now we've got the Heart.
Yeah, beautiful. John couldn't be with us this evening. Sends his apologies, but he's not well, bless him. So we hope you get well soon, John. I'll come back soon.
And here's one where he's added more data to his Andromeda galaxy.
Now 7 hours. Oh, rivals yours, Pete. Ooh. That's amazing.
Lots of data there. So he's getting there.
You can't go wrong with F31.
Yeah, we've got a few of the red nebulae around the edge there as well, showing
There you can see
a few little bits there. So well done.
Yeah.
And there's a little plug here for coming up. We've got Brian Cox doing a new series on the solar system, which starts BBC Two next Monday. So
really, I didn't know that.
No.
So there we go.
I didn't
a new series.
Fantastic.
Yes.
And I've set my recorders to record it.
Now I think there's only 5 or 6 episodes, so be aware of it.
Yeah,
although it will be
images.
on watch it if you do miss any of them.
More
So,
images of him stood on top of a mountain with the wind blowing it through his hair.
Yeah.
As you do.
I love the locations that they get to go to. You know.
Yeah. Oh, the things he has to do for the BBC.
I know exactly. Yeah.
Okay, so that's our What's Up in the Night Sky with a nice large gallery, and
lovely.
There we go.
Yeah, brilliant.
That was fantastic. Thank you, everyone. Love seeing the gallery, really do.
Yes.
Yeah.
Okay.
Fantastic.
Right.
All right. So thank you very much for that, Roger, as ever. Don't forget, ladies and gentlemen, if you would like to submit your images to our weekly viewers gallery, it could not be easier. Just attach the image to an email, one image per email, please, and email it to spaceodditieslive@gmail.com. And there we are. If you could also, somewhere in the subject of your email, put the word gallery, that will allow the Space Oddities elves to extract it and put it somewhere where Roger can easily find the images.
Yes.
But we do love seeing your images, and please keep them coming. As we always say, you don't have to have expensive equipment. I mean, Pete's image was taken just with an iPhone, for goodness sake. So it shows what can be done with just a mobile. So if you have any images that you would like to share, then please just put them in an email and address it to spaceodditieslive@gmail.com. And we look forward to receiving them because we love looking at your images so much. Right. Okay. Well, I guess that brings us to Pete. Pete, do you want to say a few words?
Yeah, I mentioned a few weeks ago that Fawkes Telescope and the Liverpool Telescope, schoolsobservatory.org, were combining. They have now combined, so both telescopes are available on the same network, and that's found at the website schoolsobservatory.org. It's free to join up, so join up. You can use the telescopes for free. They range between I think there's about 15, 16-inch Meads. There's 4 1-meter telescopes, and there's now 3 2-meter telescopes, all available for you to use. Won't cost you a penny. Sign up and use them. The La Palma telescope, the 2-meter, if anybody has been on that site, has been noticed that it's been out of action for September. That's because the mirror was being illuminized, but it's back in action now. So if you go to schoolsobservatory.org, sign up, you can use these telescopes for free. I mean, a lot of people don't like robotic telescopes. I've come across this before. But if you've got a cloudy night, which we seem to have quite a few just of late in our area, it's a nice place for you to go when you've got nothing else to do and take some images with some super large telescopes in some super dark locations.
And it doesn't matter what time of day you do, it's either.
Well, no, because some are in Australia. So if you're logging on at midday, it's midnight in Australia. So away you go. You've got all day and all night to use these telescopes. So sign up, and if you're a teacher, you can sign up as a group membership where you lead the group. You can lead your whole class, and it's all free. So just go on the site and follow the instructions and sign up for what level you want to interact with.
Absolutely.
Yeah, of course, because with being in Australia, you'll be able to catch some of those southern constellations that we don't get to see. So,
well, that's the beauty of it. That's the beauty of it.
My favourite's the tarantula.
Yeah, it's a good one.
Yeah,
it's a good one.
Okay, all right then. So thank you for that, Daz.
Hello.
Now, Daz would like to talk to you about astronomy in Lanzarote, of all places.
Yeah, we had a query that somebody's popping over to Lanzarote, and they were asking, do they do tours, stargazing tours? Now, if you just bear with me for a second, please. Now you'll see your screen change. Please don't panic. Don't panic, Mr. Mandarin. So here we go. I hope I got this right. So entire screen.
So if you are going on holiday to Lanzarote, and I know many people do, then you may want to know, what's going on in terms of astronomy you can do while you're there, because obviously astronomy, Lanzarote does have dark skies. So there you are. So Daz, what's this all about then?
Right, can you see that image of top of a mountain?
Yeah.
This is Pinas-Cash. I've probably totally murdered that.
Right.
Now this is basically.
Sorry, go on. Go on.
Oh, he's gone.
Daz has gone.
Has he gone?
Or.
Right.
Sorry.
Well, your audio disappeared then, Daz.
Oh, okay. Sorry, I do apologise. just tap in something in your search engine, stargazing or astronomy tours in Lanzarote. Now, there isn't a lot, but what there is really choice stuff. Now, this comes on here and it says a stargazing viewpoint. Now, this is actually the top of a mountain. Now, if it's the place I'm thinking of, there's a car park at the top here. And they come up, people come up here, locals come over for barbecues on Sundays and things like that. Now, these radar towers, if it's where I'm thinking of, these are obsolete now and they are dismantling them. But this happens to be the tallest mountain in Lanzarote. And apparently it is renowned for its basically being so high, it's above all the light pollution. And it's 670 meters, the highest peak on the island, and this is where people go to do their sky watching. And as I said, during the day they go up there for barbecues and just general sightseeing. It can be reached easily by car, and a parking area is provided. It says a spectacular sight of the star fields in the Milky Way on a moonless summer night. But of course, we're looking for autumn, really. Looking towards the south, you will see the most amazing sight of the Milky Way from the viewing point at Penes del Cash. Two constellations stand out in the northern hemisphere in the summer: Sagittarius and Scorpius. Shining especially bright is Antares, Scorpius, ruby red star. It says, "Can anyone can recognize these two constellations? Sagittarius looks like a teapot, and Scorpius like the long-tailed insect of the same name." So basically, it said just remember to take your binoculars, and of course, with if you're lucky enough, if you've got a travel telescope, take that along with you as well, and then you'll be amongst friends. And you can see this is some of the images that have been taken from the top of the mountain. So that's one of them. As I said, you can see on the map there where it is, and of course you can zoom in as much as you like and see on it. So that's just to basically respect the area and things like that, because this is on nature reserves. So basically, just don't leave any rubbish or anything like that around. Right there, right, here we go. Stargazer. Now, this one, if you want an observatory experience, then you can actually go to the Nazareth Observatory, which again, like I said, it's on Lanzarote, which is obvious. That's what we're talking about. And they will actually, you can actually, if you phone them, you can actually arrange a tour. They do tours which range from about 1.5 hours to 2 hours. And basically, it says here it's €45 per person. The maximum is 10 people, but they've got several telescopes that you can actually view through. But also, they will take you inside, and they will show you what they're actually looking at and what they're observing. And this is the telephone number that you need to do. Now, if you're going to book any of these tours, I would advise you to do it before you leave. So that you know you're fully booked, because some of these tours do get booked up very, very quickly. It's the same with any of the attractions in Lanzarote. Preferably book before you actually leave the UK, because they're changing the rules on Lanzarote. All attractions now, very soon you will have to pre-book before you go. It's to spread people out, to stop people going all the time. I think that's just it on there. There is a better website I did come across on this one, but that's all you need to do. Is we'll put all these links in the description at the end. And last but not least, there's let me just see. There's this chap here, cosmoslanzarote.com, and it's Astrofisco Real Martinez Morales. Now, this chap here, he does talks. He takes people out on night tours and uses a variety of telescopes to show people the night sky. He's quite well known on Lanzarote. He runs a planetarium for schools and outreach. And again, if you just contact him on the telephone number,
Daz, I think Daz's audio has gone again.
Leaflets on astronomical tours, then you're going to be unlucky there. So that's all it is. I just want to say there are things that you can do. I think the Nazareth planetarium looks very, very interesting. But also, if you've got hired a car and you fancy a jaunt up early evening to the top of that mountain, I'm not going to try and pronounce it again. And you can watch the sunset and then do some stargazing. So yes, there is. You can do lots of stargazing on Lanzarote. So just remember, we'll put the websites on in the description, so you can actually you'll be able to just click on them and see what you would choose. And as I get, if it needs a tour, then just book it before you actually leave the UK, so you won't be disappointed.
Okay.
Now, one of the things that might happen, hopefully, if I can arrange it, one of my contacts in Lanzarote is when I'm over there, because I'm going back over in December. Hopefully, we're going to arrange a night that we can pop out. I'll probably take the Sea Star or something, so it's easy to, because it's so easy to travel. We're going to go to some dark sky nights and possibly make a video, depending upon what the weather's like when we're out there. Because sometimes in the evenings it can get a bit cloudy. So yes, there you go. I hope that how shows you where to go. Oh, what have I done there?
Fantastic.
Okay, then. Thanks for that. Yeah.
I mean, lots of people do go to Lanzarote from the UK. So let's see what happens there. So
I want to get rid of this. Why won't it disappear?
I don't know.
Stop screen sharing. There we go.
There we are. Okay.
Sorry about that.
That's okay. Right. Okay. Well, moving on. We've come to the time, and we're going to talk about the 10 weirdest exoplanets. And I did ask you at the top of the program, what planets in the solar system do you think might appear weird to extraterrestrials? And Ian says, I would say Earth with its oceans and life. You'd really be only able to detect the life from very close up, of course. But if we were looking at the Earth from 10, 15, 20 light years away or whatever, you wouldn't be able to detect the life. You may be able to detect the oceans, obviously, but it's a good candidate. And somebody else also says, whoever one of us added that, I'm going to say the Earth because of the strange radiations coming from. That was Michael. Have we ever happened? Have we got any more here? Don't think that was it. So anyway, if you do have any suggestions, what planet in the solar system would look weird to aliens, put them in the chat. My nomination for that actually would be, funnily enough, Uranus, because Uranus is tipped over on its side at an angle of 98 degrees to the vertical, which would mark it out as a very strange planet indeed, because its north pole faces the sun. And that, for me, would mark it out as a weird planet. Obviously, Saturn with its rings, well, they're not going to be uncommon in the galaxy. The smaller rocky planets like Mercury and Venus, the aliens would probably say, I've seen it before. Move on, please, nothing to see here. The Earth is the obvious one, but it would depend on how far away they were and their technology as to whether they actually managed to spot anything, like the oceans, and life from very close up, as we said.
I wonder what their regulations are as of what constitutes a planet. Would Pluto fall in their realm of being a planet? Ooh.
Well, they may have.
Pluto's a planet.
Yeah. Thank you, Mr. Luddite. I mean, it would depend on so many things. They may not even have concepts of things like planets. They may have a completely different system of thinking, and they probably would, But assuming that they think sort of like us, then there you are.
Yeah, you've just got to hope when they do get closer and they do study the Earth that they don't think that it's covered in vermin and it needs extinction. So
yeah, and Derek says Earth is a strange planet because it's flat.
Thank you, Derek.
Thank you, Derek.
Derek, get your coat. It's time to go. Yeah. So there we are. Anyway.
And Ian says seriously.
Seriously, yeah. Wah, 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 wah. Okay. So we're going to have a look at the exoplanets now. So just give me a second to sort myself out here. So the top 10 weirdest exoplanets. And here we go. So these are my top 10. Don't forget, these are ones that I think are for whatever reason, really weird. And the first one is it's been called the Diamond Planet 55 Cancri E, and it's almost certain that this planet has a lot of carbon, and it's been suggested that it's because of this. It's quite possible that about a third of this planet is diamond, and Forbes took the opportunity to just as something fun to do, value that diamond, and it turns out at an estimate to be worth $27 nonillion. That's with 30 zeros behind it, or 384 quadrillion times more than the GDP of our entire planet.
Let's say that crashed the market, wouldn't it?
Absolutely it would. So let's just tell you a little bit about this. It's orbiting a sun-like host, 55 Cancri A. The mass of this exoplanet is about 8 Earth masses, and its diameter is about twice that of the Earth. It was discovered in 2004, and it was the first super-Earth ever discovered around a main sequence star. So it takes about less than 18 hours to complete an orbit around the star. And it's extremely hot, with temperatures on the day side exceeding 3,000 Kelvin. So incredibly hot planet. And the thermal emission from this planet is observed to be variable, possibly as a result of volcanic activity, which is quite exciting. It's got an atmosphere rich in hydrogen and helium, but there's been some question recently about whether that's actually the case. So this is weird because about a third of this planet may be made of pure diamond. So this is.
Okay, then. Does that mean there's 3 more planets closer to the sun before it then?
Yes.
No, because I suppose it's in what order they're discovered, isn't it? Where they put the E, A, B, C, D, E. Yeah, I think is in the order, so it might not be actually. Yeah, sorry.
But we know there are at least 4 exoplanets in this system because of B, C, D, and E. The star itself, where the naming convention for exoplanets is the star itself is A, and then the planets go B, C, D, etc., etc. Okay, so the next one is WASP 17b, also for some peculiar reason called Didzu. It's a hot gas giant that orbits its star at a distance of only about 4.75 million miles. And it's strange. Why is this strange? Well, it's got a volume more than 7 times that of Jupiter. It orbits the star in about 3.7 Earth days. It's about 1,300 light years away. It's an extremely puffy planet, about the density of marshmallow. This is why it's so very strange, because it's very big, but it's very, very puffy, if you like. And it's also got clouds made up of nanocrystals of quartz, which is quite strange as well. And it is the largest exoplanet ever discovered. So you can see, compared to Jupiter, what an incredibly massive planet that is. As I said, 7 times the volume of Jupiter. Very, very strange planet altogether. The next one, number 8 in the top 10, coming in at number 8, it's TRES-2b, also known as Kepler 1b, or if you want the official designation, well, here we go, GSC 03449-02811b. and it's located 750 light years away from the solar system. It's the darkest known exoplanet. So we've gone from the biggest exoplanet to the darkest known one. It's got an incredibly low albedo. It reflects less than 1% of any light that hits it. So it reflects less light than charcoal. And on the surface, this planet is going to be absolutely pitch black. If there were a surface, because it is in fact a gas giant with sort of similar composition to Jupiter. It's very close to its star and is therefore classed as a hot Jupiter. And it's actually concluded that the star itself is a binary star system, which with this discovery, it makes obviously the parameters for this planet a little difficult to ascertain. But this is the darkest exoplanet known, reflecting only less than 1% of the light that hits it, and it's darker than charcoal. So that's a really weird planet. Coming in at number 7, we have Kelt 9b. And again, it's a giant planet, about 2.8 times the mass of Jupiter, but its radius is nearly twice that of Jupiter, so its density is less than half of Jupiter. What makes this so strange is that it's tidally locked with its host star, and it's got a very, very, very hot surface. It's ultra hot. And the surface of this planet is about 4,300 degrees Celsius. Now, what this means is that because of the high temperatures, there are nuclear fission processes going on at this star, and it's actually creating atomic iron and titanium in its atmosphere. These are being generated from within the atmosphere itself, which is really, really strange. I've never seen a planet before where it's creating elements in its own atmosphere. So this is what makes Kelt 9b exceptionally weird. And we go from that sort of weirdness to number 6. This is known as the magenta planet because it is magenta. It's a gas giant located about 57 light years from us. It's commonly referred to as the pink planet, but observations recently have shown it's actually more magenta than pink. It's actually raised a lot of questions regarding how planets are formed. Why? Because this is an exceptionally long distance from its star. It's 43 astronomical units away from its star, which is obviously 43 times the distance between the Earth and the Sun. Exceptionally distant from its star. And the whole planet is magenta, and is visibly magenta as well, which is very, very strange. So it's been the subject of infrared studies from the Subaru telescope in Hawaii, and it's the lowest mass planet ever discovered around a star like the Sun using direct imaging techniques. So we can actually see this planet, and it is magenta, which is really, really weird. It's about 160 million years old, this whole system. And it's very strange. It's 57 light years away. So that's the magenta planet, and that alone marks it out for weirdness. Then we move on to number 5, the Methuselah planet, PSR B1620-26b. This is the oldest planet yet discovered. It's nearly 13 billion years old. So it dates to the very, very, very early universe, one of the first generations of planets, almost certainly. And there's another weird thing about this. It orbits in a circumbinary orbit because it orbits 2 stars. One of them is a pulsar and one of them is a white dwarf. And it's the first so-called circumbinary planet ever discovered. And in another first, it was also the first planet discovered inside a globular cluster. And again, weird things about this planet. But the fact that it dates to the very, very early universe marks it out as being exceptionally weird. And the fact that it's orbiting a pulsar and a white dwarf makes you realize how it's managed to survive that long, which, is weird in itself. Coming in at number 4, we have the hang on, let's move up. Sorry, number 3, Gliese 436b. This is known as the hot ice planet, and it's a Neptune-sized planet where ice exists that defies Earth-like conditions, because the surface temperature of this planet is nearing 439 degrees C, but the gravity of this planet compresses water into solid forms of ice. And this means that it's very strange that you've got ices existing in those sorts of temperatures, which is certainly incredibly weird. And it was the first one in the class known as hot Neptunes, and it's among the smallest known transiting planets in mass and radius. And in December 2013, so about 11 years ago, NASA reported that clouds may have been detected in the atmosphere. So that's really interesting as well. So the number 2 slot goes to. Hang on, just one second. There we are. My machine's lagging a bit. HD 1897733b, the glass rain planet, because this planet experiences rain of molten glass and winds up to 5,400 miles per hour. And what this also means is, because of the high winds, if you were in the atmosphere of this planet, those shards of molten glass would be coming at you horizontally. So trying to descend through that planet's atmosphere would be an absolute nightmare. And its blue color is due to silicate particles in its atmosphere. And it was the first exoplanet to have its thermal map constructed. And its deep blue color, as I said, is due to silicates in its atmosphere. And they've also detected carbon dioxide present in the atmosphere as well. So that's the glass rain planet. So you may ask, what's going to be number 1? Well, this one gets my vote, number 1. This is an incredibly weird planet. My machine would just keep up here. So there's just a bit of a lag here. 1 second. That's going to crash, isn't it? Yeah, that's crashed. Thank you, Microsoft. Okay, here we are. Let's come back. This is the Super Saturn planet. And this planet has a massive ring system, 400 times the diameter of Saturn's rings, if you can imagine that. Now, when astronomers first saw this, it's gone. Right, just give me 1 second. I will put this back for you. Can you still hear me?
Mm-hmm. Yeah.
Okay.
I think your computer's reverted back to only recognizing one core.
No, it's not. It's fine. It's fine. Just give me 1 second, and I will just put that back. Just talk amongst yourselves.
You're back now, so yeah.
Yeah. So what did you think of that, guys? Some really weird exoplanets. I'll just give you some more details about the number 1, just to finish off.
Yeah, that number 1, that's a hell of a lot of ring system, isn't it?
Yeah, absolutely.
So,
and the thing about it is that they've actually detected the fact that there may be moons forming in those rings as well. And it's just an amazing planet, 400 times the width of Saturn's rings, and that is nothing like this has ever been seen before. It's definitely one of the strangest exoplanets out there.
Yeah, did we know the mass of the planet?
Just give me a second, and if I can just restart it, I will tell you a little bit more about it. I'll just read you the notes. Okay, it's not going to restart, unfortunately. However, let's carry on, because I don't think that's going to come back. Okay, so yes, so there are almost certainly be discovered out there. I don't know whether anybody here has got any nominations for other weird ones, but
There was the planet where they said it rains molten iron.
yes, that's true. That was in there as well.
That's right.
Although,
Because it's so. Sorry.
no, I was going to say, although I was reading about that one, that more recent observations have cast doubt on that.
Okay.
But there are some very, very weird planets out there, and so far in our quest for finding exoplanets, these 5,000 plus planets that we have found orbiting other stars, we've not seen anything that really looks remotely like our own solar system. So our solar system may be exceptionally unusual. You can't say unique, of course, but it may well be, exceptionally unusual. Having said that, if you think about how many stars there are, 100 billion stars in the Milky Way, or even more, according to recent estimates. And if you said that on average each star has got 2 planets, which is what planetary scientists quote as the figure, that means out of 5, we've discovered 5,000 of them out of thousands of millions of planets that must exist in the Milky Way. So we can't come to any statistical conclusions about exoplanets and about whether our solar system is exceptionally unusual or just unusual or not at all unusual. We just don't know, because there are so many thousands of millions of planets waiting to be discovered out there, and we can't draw any conclusions from that, let alone planets in other galaxies. In our own galaxy, we're going to almost certainly find some even weirder planets. So there you are. Thank you for that. I hope you enjoyed that. And we're going to move on now to Daz, who's going to tell us what's been going up, or what's going on, I should say, with the sun this week.
Yes, there's been a bit of a below par sun again this week. So we've had 2 or 3 weeks now of low activity. So if you just bear with me, I'm just going to bring up. Right. Okay. Okay. Can you see my cursor?
Yep.
Yep. Okay, then that's fine. Usual start on the left, last week's sun where we left off, and on the right, the 1st of October, is today's sun. As you can see, we had, what was it, 8 active regions on the sun last week, with one being encircled, because that was obviously, I think, just beginning to grow. It appeared and it was beginning to grow, but they were waiting to see what it was going to turn into before they actually numbered it. And then on the 1st of October today, we are down to 8 again. Well, we're still on 8, but there's 2 or 3 regions again which have appeared. And they're just waiting to see whether or not the ones on the left, especially the one the furthest left, they may not number, because it's going to be gone in a couple of days' time, and there's very little chance it's going to do anything. But there is a small spot coming in on the east limb as well. But we do know that there's a slightly bigger spot due to appear any time. In fact, it's on the limb now. So that's what it looks like. Now, the spots we're interested in this week, or have been giving us a bit of entertainment, is 3839, which is just here, 3839, and then 3842. Look at the size of 3842. And we'll be talking a little bit more about them in a minute. But they're the ones who have been giving us a bit of entertainment. There's like I said, a lot of it's the sunspot numbers have dropped quite dramatically over the last 3 or 4 weeks. So come next week, when I'll have the results for the sunspot count for this month, we can expect that graph to actually drop dramatically. But only time will tell, and then we'll see whether or not we're actually we've reached the peak. But as you can say, it's going to takes months of different readings before we can actually purposely say yes, we are on the downside of this cycle. So that's what it looks like today. So here we go. This is the red sun. This is the 304. You can see all the actions. What has been happening is coming from the east. There is some flare flare action happening on the west, but just as it goes round the back. But you can see that we've got these energetics coming in now on the east side, and you can see they are giving us some flares. There's some nice filament action on the limbs, but these are beyond the actual face of the thing. But you'll actually see a couple of big flares pop off. We've had a few M flares. But now we come. This is the remember we're looking at the magnetic lines that are in the actual atmosphere of the sun, and you can see they're connecting. We've got quite a few actually big filaments which don't seem to be actually doing anything at the moment. But here we come round here. If you watch this area around here, see a big flare just there, and then there will be one almost towards the end. But none of these are sort of like facing. We're not expecting anything dramatic to become to. There was another big one. You just saw that on this area just around here. You've just missed it. You can go back and view it on the replay. See, there has been things going on. Now, here's the coronagraph. You can see it starts off pretty slow. Yawn, yawn. But then we do get some big fire-offs. Most of them are from beyond the limb. So again, they're away from us. Now, this one here, this was one of the ones that was on the limb. But again, they're going away from us. We haven't seen any halos that will indicate that we've got things coming our way. As you can see, you can tell by the direction that these weren't actually on the face, as a lot of these are coming from the northern hemisphere, but there's not a lot going on on the northern hemisphere. All the actions in the bottom in the southern hemisphere. So I've lost my cursor again. Here it comes. We're back. Right, now this is the synoptic diagram that I quickly ran through last week. And as you can see, this is the ones done by Spencer. This is the person who done it. And it's today's. So you can got all your neutral lines here. So that this separates from minus and positive areas. You can see that's a little minus. He's a little bit stingy with his minus sign. There's your positive. So they delineate the area where they think the neutral line is between different magnetic fields. And again, we've got a one that's completely almost like a pond. And again, that's delineating between the positive and negative magnetic fields. Now we've got an active region here. Remember, I said if it appears in brackets, it means the actual active area or the sunspots have actually retreated back below the sun's surface, but there is still an active region showing there. So that is why it's in brackets. There was an active region there, but basically it's faded away, and they're not showing. As I said last week, they weren't very distinctive, but these are.
Taz's audio's gone again.
These whole lines in this, you can say, oh, gone too far. Spoiler alert. So again, but again, if we come back over here, I said we were interested in, what did I say, 3839, which is here, just at the bottom here. Then we'll get there, and this is 3842. Now look at the mess around 3842, and remember what I said about the these four numbers up here. This is C class flares, that's the low ones. Then you got the medium or M class flares. Then you got the X flares, and then you got proton storms. Now they even are predicting that we've got a 5% chance that there could be a proton storm, and that is from 3842. There's a 90% we're going to get C class flares. I think that's 40% of M-class flares, and there's also a 10% that we're actually going to get an X-class flare from here. And of course, right next to it is the proton. They think that it could actually 5% confidence that there may be we could actually get a proton storm from this and all that. But as you can see, the more complexity there is in the areas, look at the confidence of what we're actually going to get. So following on from that, I think it's the next slide. Let me just check. Ian was asking about what the red and green meant. I thought he was talking about the image of the sun, the magnetic image of the sun, but this is what he was on about. And as I said, the green basically means these are sort of like monopoles. There's just one sort of magnetic field dominating. It's either alpha or beta. Now, once they start to, you get two. This is a beta gamma, and this is a beta gamma delta. Now, I'm just going to show you a little bit what I was trying to explain last week. What that's describing is the magnetic complexity within the active region itself. And the more letters there are, the more likely it's going to give us something strong. So here we are. Now, I've put two of them up here. This is 3843, which is a single. And this one here is 3842, the messy one that we were looking at. And this is a beta gamma delta. So this means this has got a real high complexity of magnetism in it. Now, and you can see this is reflected. Again, this is your class of flares. There's 45% of C flares in number 43, M flares 10%, and go on, Bennett. Too heavy-handed I am. But they think really saying there's no chance of an X flare from this one. But here, they're saying that there's a 80% chance of a C flare. So we've gone right up. We've jumped quite up high. We've got 25% M class flares and 5% an X flare. So what do we mean about complexity? Now, if you look at this top one, 3843. If you look, the blue and the red, they're in nice little clumps and they're separated from each other. They're not interfering with each other at all. So there's very little chance that these are going to interact and cause any major disturbance.
You there, Daz?
Red here, we've got red there, we've got blue, and we've got blue. But if you look, the blue is beginning to impose itself onto the red. And once these things, they hate being mixed up. They hate being this close to each other. And what happens is when they get this close, that's when we're going to get some big explosive. There's a good chance we're going to get some explosive action carrying on. So once this is all messed up, as you can see, it's all split up. We've got red here, we've got blue there. But this blue is actually intruding, and up here, into the red areas, and they hate it. They hate being this close together. So that's what I mean by magnetic complexity. Once they start getting mixed up and get more complex, that's what I mean when they say that we're going to get more of a chance. As you can see just on the white light imaging that this is far more complex than this one up here. You can see the umbra and the penumbras, but they're all linked together, and as you can see, they're different magnetics, polarities of the actual spots themselves. So that's what I was trying to explain to you, and I hope that explains it a bit more. So the more letters you've got, the more complexity you've got, the more mixing you're going to be having of these poles, and then you're going to get some action. So I just wanted to show you this. This is the K index and the KP index. On the left, this is for the USA. You got Boulder, Fredericksburg. I take it that's East Planetary, and the college, Boulder College. And this is, of course, on the right is the UK one. And as you can see, they do follow a close pattern, but there are major differences. As you can see, I mean, these reached up, they got up to as high as K5, whereas ours, I think the highest we got to was the green is that's a geometric storm, as it's saying, but that is, as you can see, it's a lot lower than what it is. We only managed to sort of like scrape together on the 25th. We managed just to scrape into the G1, so we wouldn't have got any auroras. But as you can see, around there's a similarity, but they're definitely not the same because we're different time zones, and we will be experiencing the activity from the sun at different times, and things are going to change. The storm is a moving, living thing. Now, this is we were talking about earlier on, what we're looking forward to coming towards us. Now, as I said, this is the 29th, so this is a couple of days old. But this spot here, as you can see, it's a very dark spot.
Apologies for Daz's audio. Keeps dropping out, viewers. Not quite sure why, but again, the perils of live broadcasting. I hope we get his audio back soon. If you have any questions for Daz, don't hesitate to put them in the chat. I'm not sure that Daz is going to come back. So I don't know if you can hear us, Daz, but if you can, wiggle your cursor about. Oh, Daz is actually... Oh, hang on. He's coming back. Are you there, Daz? Right. Okay. So I think we will just knock that on the head because I think we've lost Daz's audio. Can you hear us at all, Daz? Is your audio working? I can see your lips moving, but yeah, there's nothing happening there. So I think we'll knock that on the head. I think that was coming towards the end anyway. So there we are. And that leaves us just with three of us. Pete's had to go. Lou had to go. Michael lost his internet connection altogether earlier. So I'm afraid Michael couldn't stay around. Daz is back.
Can you hear me?
Yeah, you're back now.
Oh, that's because I must admit, when you've been talking, you've cut out a couple of times, or sort of like gone very low for some unknown reason. It
Right.
could be something to do with Restream.
Yeah.
So
it could well be.
Sorry if you didn't hear that, but there's not a lot going on. We'll just see what happens over the next week.
Yeah, and it's beginning to look as if the sun has moved past the peak of its cycle.
Yeah. Well, yeah.
So we can expect things to get a lot calmer on the sun over the coming months, but you never know because there have been solar cycles where
it doesn't just because we come on the downside. Sometimes when you come on the downside, it gets more active than what it was before, than it was at the previous cycle. So don't expect it to just die away, just slowly fade away, because what can happen is once we come that on the downslope, when sunspot numbers start to really drop, you start to get more and more action, because of course what you've got to remember, we're moving towards a major event when the poles will swap.
Yes.
And so it just means we just got to watch what's going on.
Yeah, not the actual poles, the magnetic poles.
The magnetic poles, yes. Sorry, I do apologize.
Yeah. Of course. And there's so much to discover about the sun that we don't know. We don't understand its cycle fully. We don't understand the physics of these magnetic pole swaps. And obviously there's a lot of effort going on to try and understand it all the time.
Yeah, I mean the history of heliophysics is very interesting, because it was in the 50s when I think I've shown you before the KP indexes from the decades. In the 50s, we started sort of like seriously looking out into the universe with radio telescopes, and all of a sudden they thought, well, something's interfering and we can't see anything. And then they turned them round towards the sun, and of course in the 50s the sun was very, very active. And then they said, oh, hang about, let's study this instead with the radio telescopes. And then of course it wasn't until the 70s we got dedicated space telescopes to look at the sun with chronospheres and things like that. So it is still quite a very young. But then again, our astronomy and our understanding is very young. It wasn't until the 1920s that we realized that there were other galaxies. They were nebula. They thought we were inside the Milky Way.
Yeah,
so You know,
Absolutely.
everything's young. So yeah, brilliant.
Well, I mean, the oft-quoted figure is that what we know about the universe is doubling every 10 years. And that is accelerating. And it's about to go through a massive, massive acceleration, I think, with the new generation of telescopes that are coming online over the next decade. And this will include the Square Kilometre Array, the world's biggest radio telescope ever built, which will be 1,000 times more sensitive than any existing radio telescope. We've got, of course, the Vera Rubin telescope coming online, hopefully towards the end of next year, which is a revolutionary survey telescope in Chile that's going to completely revolutionize, or should completely revolutionize, lots of areas of astronomy, giving us so-called time domain astronomy, where we'll be able to see things happening live, as it were, in the universe and track events that we might otherwise have missed. We've got the 30-meter telescope and the Magellan telescope, not to forget the European Extremely Large Telescope, which by current estimates should be seeing first light sometime towards the end of 2026. It's still under construction in Chile. The biggest optical telescope ever built, with a 39-meter mirror. That's going to revolutionize things as well. And the amount of data that these telescopes are going to generate is truly amazing. And it's just lucky that artificial intelligence has come along, because it will enable us to process data in ways that would have been very difficult without it, because of the petabytes of data that these incredible new machines are going to generate. Then, of course, we've got lots of upcoming new telescopes in the realm of gravitational waves. We've got the Indian LIGO that is under construction. We've got the LISA space-based astronomical telescope, the Gravitational Wave Observatory, which should be able to directly detect gravitational waves from co-orbiting supermassive black holes at the heart of galaxies. We've got the European Einstein telescope, which they're just finalizing where it's going to be built at the moment, but it will be an underground gravitational wave detector, much, much more sensitive than LIGO. All stand to make incredible discoveries. So it's a really exciting era to live in for astronomy, because we're on the verge of a revolution in astronomy, basically.
Yeah, our knowledge is expanding like the universe.
Yeah, and the era that we are just starting now, because of artificial intelligence, apparently has been dubbed the information age. And we had the digital age, but now we're going to have the information age. And the same is true in astronomy. It's going to be data, data, data. So my advice to any youngster wanting to get into very exciting areas of astronomy is to go into data science, because that's where the jobs are going to be in astronomy. So there we are. All right, then. Now, I think unless anybody wishes to add anything, I think we'll draw things to a close for this evening. We'd like to.
We're going to have to hunt down these gremlins.
Yeah, absolutely. Yeah, we seem to be beset by.
Yeah, and I'll just apologise to the people who really struggled to find us at the beginning. I did see your comments in chat. What you'll have when we go back, Andy, you'll have to pop the poster onto this stream, because the other stream cut off. So we had two running at the same time.
We had a problem right at the beginning, but luckily we resolved it.
Sorry about that, folks.
So totally beyond our control, I'm afraid. But yes, so we'll draw things to a close. Don't forget, as I said at the top of the program, that we are going to have two of the Polaris Dawn astronauts as guests on Space Oddities later this month. What we would like to do with this is turn it into an event for schools to get kids asking astronauts questions. We'd like to involve schools from both the UK and the USA, obviously at the same time. And what we're trying to do at the moment is get a date and a time together when that can happen. So we're chatting to NASA at the moment about that, not helped by the fact that the US clocks don't change at the same time ours do. So we've got that added complication. So we are talking to NASA about this, and hopefully we can come up with a solution and get the kids involved, because when we were young, astronauts were our heroes. If I remember correctly from my childhood, because I grew up in the Apollo era, you either had astronauts as your heroes or you had footballers as your heroes, sometimes both. But astronauts were my heroes when I was young. So we'd like to give kids an opportunity to talk to the astronauts, because kids are the future, obviously. But we will keep you posted. We may not be able to do it, but we will see. And
maybe if they can record their questions, then we can pop them up, and then the astronaut can reply then, and then they can watch
absolutely,
it on the show later. Yeah,
yeah.
where there's a will, there's a way.
Where there's a will, exactly. And we're always trying to do our best to bring you interesting guests on Space Oddities. We always have, and we always will. So, so there we are. So thank you all for being here this evening. We'll be back at the same time next week, obviously, with more stuff. Don't forget, we've got a guest from Britain's Spaceport at Saxavort on the program in 2 weeks. He should be really interesting to talk to. So you'll be able to ask him your questions. And that's it. And don't forget, please, if you haven't subscribed to the channel, then why not? Because if you're subscribed to the channel and you can join the Facebook group, please remember to leave a like and hopefully a comment in the video as well after it's been published. So we'd like to thank you for that, because it all helps us get noticed by the YouTube algorithm. All these things are important, and it helps YouTube recommend our videos to people it thinks might enjoy them. So anything you can do to help in that respect would be much appreciated. And just before we go, don't forget that if you would like to support Space Oddities, then you can buy us a coffee by scanning this QR code. And thank you for that. We need our caffeine uptake maintained. And other than that, you can use a super chat, which is the dollar icon under the chat window. And any contributions towards keeping the show on the road, as it were, much appreciated, because we can't do it without you, basically. And thank you very much for that. So I'd like to say good night to Aaron. Aaron, lovely to see you. And I'm glad your video is sorted out now. It's been a while, but we got there in the end.
Yep, much better.
Much better. What did you do to fix it? Did you get a new camera?
No, well, yes, but that didn't seem to fix it. I have no idea what the solution was. Things are not perfect on my end, but as long as it's working on your end, that's really what matters. So
absolutely, it is. Yeah. So we're really glad to see you without you looking like you're a cast in a film of stop motion animation. So that's great. We're glad to have you smoothly, sir, for once. And there we are. Roger, thanks for the nice guy in the gallery, as always.
No problem.
And we look forward to seeing you next week. Daz, thanks for your solar stuff and everything else. So,
my intermittent solar stuff, yeah.
Yeah. And don't forget, guys, keep an eye on the Facebook group, because that's where we tell you what's going on. And also, as I said earlier, don't forget, we've got the chat there on the Facebook group called Your Astronomy Events, where you can post details of upcoming astronomy events you think people might be interested in, and also see, obviously, the other events that people are posting. So if you want to know what's going on in terms of astronomy events, and they're all UK events at the moment, then do have a look in the chat on the Facebook group. So from all of us at Space Oddities, have a fantastic week. Look after each other. Be good. And we will see you at 8 p.m. UK, same time, next Tuesday for more fun and frolics